Okay, problem 16 through 20 from the first test, practice, mechanical practice. Vertex and another point. I will say at the start from 4 to 9 is linear change. And in a quadratic, the conversion ratio is based on quadratic change. All right, size of a square is 5 units long, its area is 25. All right, so quadratic, x minus 4 squared plus 7. And when you drop a 9 in, the change in x is 5. But the change is being squared, and it's all about the numbers working out here. All right, so how do we get from 7 to 30, up 23? And the quadratic change when you put a 9 in is 25. All right, let's continue this. Minus 8, 3. X plus 8 squared is quadratic change as measured from -8. What is the quadratic change from -8 to 1? 81 units of change. Drop a 1 in. 81s cancel. How do you get from 3 to -17? Down 20. -5, -2. Let's get the trusty card over here. -5 minus 2. So x plus 5 squared. That's the smallest square area we can have. There's a minimum at -5. And 0 squared is a minimum. So we want -5 to act like 0. Make that statement. Geometrically significant. All right. How do we get from the vertex -2 to 21? Looks like we're going up 23 again. And the quadratic change is -5 to -9. The linear change is 4. Backwards 4 actually. But we're squaring that, so 16 units of quadratic change. And there's our y equals statement. Get an eraser here. Make some room. Get rid of the Jackson Pollock. All right. -328, so x plus 3 squared plus 28. What's the quadratic change? 9 units of quadratic change. And from 28 to 0 down 28. There's our graph. Y equals, see a 5 and a 7. X minus 5 squared. Oops, I better move the card a little bit. X minus 5 squared plus 7. Quadratic change from 5 to 11 is 36 units of change, but we only want 43. Rise over run squared is measured from the vertex. Now we're solving equations. All right, and this is a cup shape up. Y values have to be bigger than or equal to 7. That one is. So we have real roots. So 50 minus 7 is our first step. We're going to divide by 2, and then we're going to take the plus minus square root. All right, let's do it in stages. All right, this is in vertex form, by the way. X minus 0 squared plus 7. Don't have to write that. So we're subtracting 7, 43. We're dividing by 2, 43 over 2. And we are taking the square root, which has a plus and a minus possibility. Done. All of these are in graphing form. One of the reasons you put things in graphing form is it makes it easy to solve. Cup shape up from 9, real roots. Take 9 away from 20, you got 11. Divide by 3, and take the plus minus square root, and measure from the number 5. Cup shape up, measuring from 2, imaginary roots. When you square, you get positives. Add positives to 2. Generally, you're going up. The only time you don't get a positive is when x is 0. So 0, 2 is the vertex. This could have been written as x minus 0 squared plus 2. We're trying to hit -50. You're imagining things. Minus 52 divided by 2 is minus 26. Plus minus the square root. And those are imaginary roots. Moving on down the line, getting mechanical practice. Talk about concept in class. Add 10, divide by 3, plus minus the square root of 10. Addition of 2 becomes subtraction of 2. So, that cup shape. We want to hit a height of 20. And we are measuring from -2. If I move over a little bit more than 3 units, the square root of 10 is a little bit bigger than 3. I'm near the number 1. And if I put something near the number 1, I should get close to 20. Remember, that's the exact answer. Minus 2 plus root 2. But 1 plus 2 is 3. 3 squared is 9. Times 3 is 27 minus 10 gets me 17. Right? And this number is a little bit bigger than 1. Stands to reason. It's going to get me something a little bit bigger than 17. Cup shape down. Starting at a height of 40. Yeah, we're going to hit 0. So there's minus 40 divided by minus 5 is positive 8. Plus minus the square root of 8. And I hope that you would say plus minus square root of 4 times square root of 2, which is plus minus 2 root 2. Oh, there's our 1.41 again. So doubling this is close to 2.82. If I put plus or minus 2.82 in here and square it, I should get the number 8 times negative 5 is negative 40 plus 40 is 0. Now I'm going to do some logs here. And again, you need to know the language. When you see log, you've got a base, and you're wondering, what do you put it to get 27? Okay, and that's exactly what we did in one of the previous 5 problems, except you have to make that statement. All right, so kind of running out of space here, but it looks like we need to flip it and we need to cube it. Flipping it makes 3 cubed 27. So that's our answer. We need a reciprocation and a cubic. Reciprocate the base and cube it. All right, now I got some space here. The final frontier. So you need to make the statement 4 to the what equals 1/8. Well, 4 is 2 squared, so that's 2 to the 2x. 1/8 is 2 to the negative 3. There's our minus 3/2 again. I seem to have the same problems over and over and over again. All right, what's the exponent you put on top of a 5 to get a 1? You're supposed to know that 0. So 1/9 is 3 to the negative 2. I'm raising that to what x to get 3 to the 3? God, there's our minus 3/2 again. There's only so many you can do. All righty. Mechanical practice. Hoping you get some more checks through reps. Okay, so this is 64 to the x equals 1 over 16. I got a feeling you're supposed to know that 4 cubed is 64. 4 times 4 times 4. So 4 to the 3x equals 4 to the negative 2. There's our negative 2/3. Well, at least that's not negative 3/2. So x equals negative 2/3, which means I'm supposed to take the cube root of 64, which is 4. I'm supposed to square it, which is 16, and I'm supposed to give it a reciprocal, which is 1/16. So how do you answer this? You say that I'm looking for what exponent? That one. Because that's the exponential activity on top of this base that produces that quantity. All right, now from algebra 1, I hope you know the difference of 2 squares is the sum of the square roots times the difference of the square roots. X plus 5 times x minus 5. Let's put a 1 in, or 6. Let's put a 6 in. I think that gets 11. 1 times 11 is 11. Let's put a 6 in. 36 minus 25. I think that's 11. Sure looks like it's the same calculation. All right, so what do we have here? We got a parentheses times a parentheses. Middle term's negative, end term's positive. It's got to be minus minus. Minus times a minus is a plus. Right? 2 numbers that multiply out to 6 and add up to 5. 2 and 3. A times A. It's another way of saying A squared. Looks like I got to have a plus and a minus. Let's make that a little larger. And I'm looking for factors of 18 that are 3 apart. Sure looks like a 6 and a 3, and I want the negative. I better put the bigger one with the minus sign. Continuing right along. Trying to get a little practice. Oh, I see a common factor. I know that's the first rule of factoring. Take out what's common. Oh, yeah, there's one of those positive negative situations again. I guess I gotta have a negative negative and an x and an x. And two numbers that multiply out to 6 and have something to do with 7. Sure looks like 6 and 1. Multiply that out. You know, we could plug in a number and see if it works. Let's plug in a 1. Oh, that's 0. 1 gets you 0. I wonder if a 1 gets you 0 up here. 2 minus 14 plus 12. Sure looks like anecdotal proof here. 3a squared. There's only one way to get 3a squared. That's 3a times a. Bunch of ways to get 4. 1, 2, and 4, but those numbers are going to be tripled. I don't think I want 4 times 3 is 12. I don't even think I want 2 times 3. I think I want 1 times 3. I don't think anything else is going to work. And if that's a 1, that's a 4. Oh, 3 and 4. 3 and 4 are 1 apart. I think I want a 4. That one to be the minus. All right, graphing form for a quadratic. It's not hard. All you got to do is find the vertex. You're already given the a term. So another way of writing this, another way of writing 2x squared plus 12x minus 5 is to display the vertex. Right, so how do we get that? Minus b over 2 times a, negative 3. So I'm going to say plus 3. Then I'm going to put negative 3 in. That's 18 minus 36 minus 5. That's minus 18 minus 5. That's minus 23. I now can see cut shape up. Negative 3, negative 23. And for 2 points in graphing, might as well get that practice in. The y-intercept's negative 5, and that's on the increasing side. Increasing side. It's also bigger than negative 3, that x. That's got to be worth 2 points, and that's got to be worth a point. There's like 3 points coming from this. All right, so minus 2x squared, don't forget the square, minus b over 2a. That's negative 5, so I'm going to write x plus 5. If I plug negative 5 in, I get negative 50. You know, let's do it a different way. Let's put 0 in. If I get 0, I get 50. I don't want that. Because if I put 0 into the original, I get 3. That's actually quicker and easier. So feel free to do that. This one here, 4x minus 8 divided by 8. Right? 2 times 4 is 8. Negative 1, so I'm going to say x plus 1. I'm going to put a 0 in. I want it to come out as minus 9. 0, 0, minus 9. Right now it comes out as 4. I don't want 4, I want minus 9. So it looks like the vertex, cup shape up, negative 1, negative 13. And 0 is to the right, so I must be on the increasing side. Yes, I was. And 0 gets me negative 9. All right, minus 3. Well, that's going to be one of these cup shapes right now. Can you see? Not really. Yeah, that's a little better. Let's do this work above that problem. Oops, there goes the marker. All right, so I got a cup shape down. Minus b, minus 30 over minus 6, positive 5. If I put a 5 in, that's 150. This should be minus 75, it is. And that's 7, and if I put those things together, I should get 75 plus 7, I should get 82. But I'm going to do it this way. What did we say it was? 5? So x minus 5 squared. All right, if I put a 0 in, I should get a 7 out. What do I get if I get a 0 in here? Minus 75. I'll get rid of that. And then I'll bring in the 7. So there's my vertex. I should have a 0 on the left because 0 is smaller, which means my middle term should be negative. I said something wrong here. Oh, I'm on the increasing side. That's right. So that's the increasing side. Yep. So it should be positive. It is. And 0, 7, which means that over here, 10 should give me 7. Doesn't hurt to plug a 10 in to see it come out as a 7. 10 minus 5, 5 squared, minus 75 plus 75 leaves 7. All right, last one. Just getting some more mechanical practice. All right, I'll try to Stay to the left of that. So we got a 2, an x squared. 2 times 2 is 4. 4 goes into positive 40 10 times. So minus 10. If I put a 0 in, I've got 200 coming out of this. I don't want that because when I put a 0 in, I get 11. You can write it like that for me, and you're fine. Right. So there's your 2x minus 10 squared minus 189. Right. And let's graph that. Cup shape 10 minus 189. Zeros to the left of 10, so it should be on the minus side. It is 0, 11. And 20 should get us 11. So let's solve this thing for 11. Let's see the number 20 come up and the number 0 come up. So what do? We add 189. Did I make a mistake somewhere? I don't like dividing 189 by 2. I'm not getting those integer answers. So hang on here. No, I don't like this. So minus 40 becomes positive 40. 2 times 2 is 4. So that's definitely 10. Minus 400 cut in half. Minus 200 plus 11. Minus 200 plus 11 is 189. It's negative. I like that. If I put a 0 in, I get 11. Oh, not too smart here. I was thinking roots. That's what we were doing before. So I have muscle memory. Adding 189 to 11, excuse me, is 200. Right, that's gone. Dividing by 2 is 100. Yeah, obviously the brain's getting a little tired here doing all these videos. Plus or minus the square root of 100 is plus or minus 10. And I'm measuring from 10. 10 plus 10. Oh, that's the 20. 10 minus 10. Oh, that's the 0. Both of those numbers get us 11. Okay. What are we doing here? We got no, up to 20. Only 30 more problems to go after this. Oh my. Hope you look at these. Certainly putting enough time and energy into making them.